humanity has been breaking the wall that have caused limitation in themselves. Sometimes they forget that they are also part of the world. In this context, the never-ending problem of trash, especially in watershed, is the wall in which many people have been trying to solve. One concrete way to solve this problem is through innovation and research.
But how bad is this problem? Think of this scenario. Suppose a person is dumping trash to the river. The trash will be drifted along with the flow to the downstream. There are a lot of possibilities here. One is the trash successfully captured by a trash screening apparatus in the form of trash rack. However, the trash can accumulate and create trash buildup and eventually block the river flow. The other is the trash can continuously be drifted along the river to the estuary and finally to the beach or the oceans, or instead to the small channels. Both possibilities can emerge another problems such as flooding and unstable irrigation supply. Building up on this scenario, our SIII-GACA team, which consists of Prof. Ari Subagya PhD, Oka Darmawan, Brahmandas, Arya Winata, proposed a new design of a waste capturing apparatus in river flow, known as Smart Integrated Flexible Garbage Capturing Apparatus, or SIII-GACA. This apparatus consists of Waterwheel as a rotation generator, the modified design of screw conveyors in horizontal positions used for capturing and transferring the trash, inclined screw conveyors modified with the design of an array of bars which is used for passing on the trash to the containers, and the flexible joints. In this design, we also implement the floating mechanism in order to make the apparatus more flexible and adaptable with the fluctuating flow of the river. This is inspired by the floating mechanism in floodplain. As a consequence of more flexibility, a Garbaratha or jet bridge concept is also applied as the cover of the inclined screw in order to prevent failure in the joints. An IoT-based monitoring system is applied in this apparatus, which consists of ultrasonic sensors for monitoring the fullness of the containers, laser sensors to monitor the rotation of the apparatus, and water flow sensors. The whole data is processed and transmitted by NodeMCU to the Google Firebase as data platform. This monitoring system will increase the work efficiency of the maintenance worker as it is accessible in real time. The data obtained can also be referenced by the local government as the tracking system of the river's behavior and as the mitigation of catastrophic events such as massive flood. We've conducted several tests for the design of this apparatus. In the simulation test using computational fluid dynamics methods ranging from 0.53 to 1.34 meter per second speed of river flow, the performance increased using the floating mechanism is 58.81 up to 62.25% compared to without using floating mechanism. We've also done some calculations on the buoyant force acting on the apparatus, and later found that with the design of the floating support, the buoyant force increased 36.1% and theoretically confirmed that the apparatus will float. To verify the theoretical analysis, the 3D printed model was investigated by testing in real conditions. We found that the apparatus is still able to work properly with angular speed of 26.3 to 82.6 rpm. In near future, we hope that the real implementation of this apparatus can be achieved in order to break the wall and also contribute to the UN's 2030 agenda for sustainable development. Being one of them is preventing the increasing amount of pollution in oceans, seas, and marine resources, and also to contribute to our local decorations. As we are also part of the wall, ending this problem will not be enough by creating an apparatus or doing research, but with our contributions by limiting trash generated and also stop littering to the river flow, we surely will.